All right, let's do some more examples with simplifying exponential expressions. So when you have radicals or root functions, you can always represent those roots as exponents. So we in Algebra 2, like we said, we talked about how the power remains a power, or excuse me, remains in your numerator. So if I have, for example, x to some power and then, oops, the radical of that, and then what type of root it is your index. So that rewrites as x to the power, wow, power over index. Okay, as your exponent. So we're going to go ahead and rewrite this one. So this will give me x to the, my power is 6, and then my index, the type of root I'm taking is 5. So x to the 6/5. This one would be x to the 3/8 power over index. This one is a little bit tricky. So we have 1 over, that looks like, that there's no index there, it's a square root, so it would be 1 over x to the, oops, give myself a little more room, x to the 5/2, okay? Or 1 over x to the 4, goodness, x to the 4/3. Okay, so those are all ways that you can rewrite radicals as exponents. You could also rewrite exponents as radicals or multiply them together. To simplify things, you very often have to work with them in fractional form, but then at the very end, we would like to leave them as radicals for the most part. So in this scenario, when I have x to the 5/2 times x to the 3rd, what we're really doing is x to the 5/2 plus 3, right? So let's go ahead and do that in your calculator. So when you do that in your calculator, you literally type 5 divided by 2 plus 3. So it should look like 5/2 plus 3. And when I hit enter on that, I get a decimal, which is 5.5, which is not super useful. But again, we know how to change decimals back to fractions by hitting math, enter, enter on our graphing calculator. Oops. So then we end up, math, enter, enter, with the fraction x to the 11/2. If we wanted to rewrite that as a radical, which I would recommend practicing both ways, in its most simplified radical form or in its radical form, you get x to the 11th. That's the square root, right? That's your power, there's your index. If we wanted to take it even one step further, which I think Delta Math will do, I don't mind if you leave it here on like practice problems and stuff like that, but in Delta Math, they'll take it one step further and they're going to break it down into how many pairs, since we're looking for a square root, how many pairs of exponents or pairs of x's can you pull out? Because really, if I have 11 x's underneath there, give myself a little more room over here, right? I'm really taking the square root, and there's 11 x's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. How many pairs of those can I take out front? 1, 2, 3, 4, 5. What happened to my last circle there? 5. There we go. So really, I can take out 5 pairs of x's or 5 groups of x's, and then there would just be 1 x left over with my square root. So again, I am perfectly fine if you leave it right here. But if you want to take it that one step further, and I think in some of your Delta Math, it will require you to do this. So I wanted to show you an example of how, okay? There's also in the Delta Math example video examples of how to do this. All right, let's keep going. So x to the 6/7 divided by x to the 4th. Oof, this would be an example where it might actually be nicer for you to do that subtraction problem, right? So if I do x to the 6/7 minus 4, let's do that in my calculator, 6/7 minus 4, and then I'm going to hit math, enter, enter. So really this is giving me x to the negative 22/7. When you have a negative exponent, that means we're living on the wrong side of the fraction technically, right? So we can move it to the denominator. So then I'll have 1 over x to the positive 22/7. And then to write our answer all the way, we rewrite it in our radical form. So x to the 22, your power, over your index, which is 7th. Okay, let's do this next one. X to the 7/5 times x to the negative 8/3. So I'm really doing x to the 7/5 plus, oh, I guess minus. We'll keep it as plus and negative. All right, in your calculator, do 7 divided by 5 plus negative 8 divided by 3. Math, enter, enter. And I really get x to the negative 19/15. Move it to our denominator. So I'll get 1 over x to the 19, oops, give myself a little more room, x to the 19/15. And then I can rewrite that using power and index. So 1 over the 15th root of x to the 19th, power, index, beautiful. All right, this is the first one we've seen with fractions where we have an exponential expression to another exponent. So you're doing a power to a power. And so you're going to go ahead and multiply these fractions. When we multiply fractions, we can go straight across the top and straight across the bottom. So you'll really end up with x to the 8 over 27. And I don't believe that reduces. You can always check it in your calculator. 8 divided by 27, math, enter, enter. Nope, we're good. And so then now I just have to rewrite it in radical form. So it would be the 27th root of x to the 8th. Awesome. I should give myself a little more room for all these. Sorry about that. Okay, for this one I have a quotient and I have an exponent. I can go ahead and distribute that exponent because you have no addition or subtraction happening here. So when I do that, I get 1 to the negative 2/3 over x. We have a exponential expression to an exponent, so you can multiply. When I do 3 times negative 2/3, again, you can either do it in your calculator or you can treat this as a 3 over 1 and just multiply straight across the top and bottom. It should end up being a reduced fraction of negative 2. Well, I guess not a fraction at all then. If you don't know 1 to the negative 2/3 by heart, that's fine, but if you put it in your calculator, it'll come back as 1, believe it or not. And then I notice that you have an x to the negative 2 in the denominator. So I can go ahead and stick that up where it belongs. So I really guess I don't have anything left in the denominator actually. So I'll just have 1 times x squared, which is just x squared. Awesome. All right, and then we have x to the 1/3 over x. And so again, if we don't feel very comfortable figuring out like where do you have more x's, how many more with fractions, you can always do the subtraction piece now, or using our calculators to really help us here. The secret exponent in the denominator is a 1, so x to the 1/3 minus 1. If you do that in your calculator, 1/3 minus 1, and then math, enter, enter to change it back to a fraction. We get x to the negative 2/3. That's living on the wrong side of the fraction, so I'm going to move it down to the denominator. So it'll be 1 over x to the positive 2/3, and then I can simplify it as my radical, power over index. So x squared, and the index would be cubed. All right, let's do these last ones here. So in this problem, I can go ahead and distribute my 1/2 because I have no addition or subtraction happening there. So I have 9 to the 1/2 power x to the 1/2 power times 4 times x to the 1/4 power. All right, 9 to the 1/2 power is, if I rewrote it using my radicals, that'd be 9 for square root. So really I get square root of 9, which is 3. Okay. X to the 1/2 times x to the 1/4 means you do x to the 1/2 plus the 1/4, which really means if I do 1/2, 1 divided by 2 plus 1 divided by 4, math, enter, enter, I get x to the 3/4. And then don't forget this 4, he was just hanging out as well. So then I'll end up with 3 times 4, which is 12. And then x to the 3/4 written as a radical would be the 3rd root of x to the 4th. Okay. Oh man, over here we got lots of things happening. So let's see, we can start working from the inside out. So I'll go ahead and distribute this 2 ninths here and here. And so then I have 2 to the 2 ninths, and then b to the 2 ninths. So make it look like an actual 9. Okay, that's still to the third. We're going to have to distribute that 3 as well. Goodness. Times, over here I can distribute that 1/3 because I have no addition or subtraction happening. So 2 to the 1/3, b to the 1/3. All right, next step, go ahead and distribute that 3 now. So I'll get, if I do exponential expression to a power, I'll get, so 2 divided by 9 times 3, power to a power. Math, enter, enter. So this is 2 to the 2/3, and then this will be b to the 2/3 as well, times 2 to the 1/3, b to the 1/3. Oh, this is going to end up actually kind of nice, because you'll see. So when we do 2 to the 2/3 times 2 to the 1/3, you have to add those exponents. So 2/3 plus 1/3, if I do that in my calculator, 2/3 plus 1/3, I get the number 1. So it's just 2 to the first, or regular 2. And the same thing will happen with your b's, right? B to the 2/3 times b to the 1/3, you'd have to add those exponents. So 2/3 plus 1/3 would give me 1. So your answer is actually just 2 to the first, b to the first, or 2b. All right, I don't think I'm going to have enough time to finish these other 4, so I'm going to go ahead and pause now, and then I'll just real quick make a last video with these 4 in it.